Okay, if we look at 34, what volume of chlorine gas at 42.0 C and 1.33 atmospheres is required to completely react with 41.5 grams of phosphorus? So we would go from grams of phosphorus to moles of phosphorus, moles of phosphorus to moles of chlorine. And then from moles of chlorine, we get the volume of chlorine either by the ideal gas law, B is equal to nRT over P, or the molar volume. We'd calculate the molar volume at 42 C, convert that to Kelvin, and 1.33 atmosphere. So it's similar. How many grams of water must decompose by electrolysis to produce 23.9 liters of hydrogen measured at 28 degrees C and 728 torr? So we need the balanced chemical equation for this. That would be shown here. 2 waters yields 2 hydrogens plus an O2. And then we need to go from liters of hydrogen to moles of hydrogen. So how are they doing it here? What they're doing is they're not using the molar volume. What they're doing is they're just using the ideal gas law to calculate the moles. So the moles is equal to EV over T. Plug that in, we have 0.926 moles. Once we have the moles of hydrogen, then we'll go moles of hydrogen to moles of water, moles of hydrogen to moles of water, and then moles of water to grams of water. We get that there. So just standards for geometry problems, just with the additional step. Going from liters to moles or moles to liters. What volume of hydrogen gas at 29 degrees C and 0.809 atmospheres is produced when 31.8 grams of iron react completely? So we would go from grams of iron to moles of iron to moles of hydrogen. And from moles of hydrogen, we get the volume of hydrogen, either by using the ideal gas law or the molar volume. This is how they're collecting the hydrogen gas. It's bubbling up through here, and they're collecting it in this bottle. What they do is they fill this bottle completely with water, and then they let the hydrogen gas bubble up here. As it bubbles up here, it just pushes down the water level. And so they trap the hydrogen in this container. That's called capturing the hydrogen gas by water displacement. The reaction chamber in a modified Haber process for making ammonium by the direct combination of elements. So this is again just a gram to mole, mole to mole, mole to volume. How many grams of iron are required to completely react with 5.49 liters of oxygen? So we're going from liters of oxygen to moles of oxygen, moles of oxygen, moles of iron, moles of iron to grams. So the only thing is the liters to mole conversion using the ideal gas law or molar volume. When properly detonated, ammonium nitrate explodes violently, releasing hot gases. So ammonium nitrate solid decomposes into dinitrogen monoxide, N2O, and dihydrogen monoxide, H2O. In other words, known as nitrous oxide in water. If the total volume of gas produced, both dinitrogen oxide, usually a lot of people call it monoxide rather than monoxide, and steam is 82.3 liters at 447 degrees C and 896 torr. How many grams of ammonium nitrate exploded? And so this is different than all the previous problems we looked at. What's different about this particular problem? In all the previous problems, they told us the volume of a specific gas. In this particular problem, they tell us the volume of a mixture of gases, the combined volume, because we're forming both the nitrous oxide and this water is gaseous. And so we've got a mixture of gases here. And so how do we handle this now that we have a mixture? Well, normally what we did in the past with mixtures is what? We knew the composition. We either had the percent composition or we had some other composition. Do we know the composition of this mixture? Normally, if you have a mixture, let's say you have a mixture of salt and water. In a normal mixture, you can mix it in any ratio you want. You know, you can have it really salty or not so salty. You know, it's your choice, right? In this particular mixture, can we have any amount? Like, say, for example, I want more. I want 99% nitrous oxide and 1% water. Is that possible for this particular mixture? And the answer is, it's impossible. It's impossible because, you know, the mixture is going to come from ammonium nitrate, and that mixture is going to form in what ratio? It's going to form in a 1 to 2 ratio, right? I can't have a 99 to 1 ratio. It doesn't work. It's like water. You know, can I have any ratio of hydrogen to oxygen I want? No, it's fixed. It's fixed at 2 hydrogens and 1 oxygen. That's why in the previous equation, in the previous balance equation, was 2 waters goes to 2 hydrogens plus 1 oxygen. So it's a 2 to 1 ratio. Well, this is going to be a 1 to 2 ratio because of how that mixture is not a mixture that people mix up. If it's a mixture that people mix up, you know, 1 dash of salt, 1 dash of water, and then they can put it. This mixture comes from a chemical reaction and stoichiometry. So why don't you try this problem out? Let's see what you get.